Hey folks, how's it going? Thanks for joining us for the Graveyard Shift, the very last presentation of the day. Appreciate you all coming along and staying awake. Hopefully everybody is suitably caffeinated. Today we're going to be talking about MAD for mobile, where MAD is an acronym for Microservices, Agile, and DevOps. And we're going to jump into each of these three topics in a moment. My name is Cian Clark. I'm a software engineer with the mobile group in Red Hat.
I'm John Frizzell. I'm the chief architect with Red Hat Mobile.
I'm Philip Hayes. I'm an architect in the Red Hat Mobile practice.
So now you know who we all are. We're going to talk a little bit about the Mobile Center of Excellence and try and establish a little bit of a need for this concept. So one of the trends that we're seeing is that as enterprises try and branch into mobile app development, they're starting to pay hundreds of thousands of dollars for mobile apps on a piecemeal basis. Marketing comes and says we need an application. They shell out to a third-party development agency and they charge them an awful lot of money. And as this happens more and more and we grow from an organization building one application to 5 to 10, that just doesn't scale. So there's a much better way of building applications than charging a huge amount of money for each one. The other thing is the development time that we're seeing, this kind of 6-month, 12-month development cycle for a mobile application. It's just too long. It can be much quicker. And if we move at a much more agile pace when doing our development processes, we can really speed up the time to market. Mobile apps also don't need to live for decades, and I think that's a kind of an interesting observation. Traditional software systems last for a very, very long time, but the reality is these things are changing at a really rapid rate. And as new device form factors like the iPad Pro or the larger tablets, and as completely new types of devices like virtual reality and wearables come on stream, it's establishing this need for new form factors and new types of application altogether. So the idea of an application lasting for 10 years is almost laughable. And applications can live for a couple of years, a couple of weeks, or maybe even just a couple of days. A couple of years ago, 2 years ago now I think, a rail agency that was one of our customers had a scenario where they built a mobile application to capture data for flooding. There was a huge kind of slew of storms in the United Kingdom, an awful lot of rainwater gathered on the tracks, and they needed to very quickly get a picture and an accurate assessment of where all of the damage was. So they built an application overnight using rapid mobile app development technology, deployed the application to their workforce, and were able to get an insight into where all of the problem areas were almost immediately. So that's a real lesson in kind of application lifecycle and this change from living forever and ever. The other big change is that applications no longer need to be big monoliths on the client side. And we'll explore microservices in a little bit, but there's also this idea of micro applications, small client sides, small applications that are fit for purpose and do one task well. A really good example of this is the Facebook app. I'm sure everybody has seen the Facebook app. Up until about 2 years ago, the Facebook app did everything in one application. Messenger, photo library organization, automatic uploads of photos, all from one single app. All of a sudden, Facebook discovered that they were actually exceeding the limits of the iOS SDK. Things like core data and UI scroll views were no longer scaling to the amount of data that the app needs to show and the amount of functionality that the app needs to contain. And so in the consumer market, they started splitting up their application into smaller, purpose-built apps for things like messaging, photos, and so on. And so I think enterprises can probably learn a thing or two from this as well. So why exactly do you need a center of excellence? Well, it's quite valuable, I think, to have in-house skills for this kind of important delivery mechanism of mobile, rather than trusting an agency to build all of your mobile practice. It's really good to have your strategy and your design thinking influenced by iOS and Android developers, by microservice developers that actually work for your organization and have the interests of your organization at heart. This doesn't mean you need to build a development team of 30 people building iOS and Android apps, but 1 or 2 senior developers is a good place to start to help kind of influence the strategy of your center of excellence. You also don't need to move at the pace of corporate IT and move more towards a kind of a fast IT mindset. Things happen in weeks and not months. No need to file a ticket in the system. Move fast and break things. So mobile is quite different as well. There's a lot of different considerations for mobile. Lots of small applications exist rather than just big systems, maybe a handful of big systems. And there's very fast update cycles as well, as new functionality gets rolled out to mobile applications all the time. There's an expectation that you're going to be delivering by the week and not by the month or the quarter, so it's very different. Another interesting observation that a lot of people don't think about is that the center of record has moved with mobile devices. And sure, the center of record can still live in the back-end system, but these things here are also a temporary, transient center of record. If you think about building mobile applications from the very beginning with offline support, you've got your own little backup center right here in your pocket. And the idea of the mobile app storing data offline while a field service worker is in a tunnel or something is a really different mindset from the kind of typical big monolithic application that sits on a desktop computer, where records are right away sent through to the back end and live there forever, evermore. So you can almost afford to have components of your back end fail or components of your back end have downtime, and you've still got a resilient system where you can store the data right there in your pocket. And that's kind of typical of the microservices architecture as well. No service is too big to fail. So we're talking about reinventing the rules, and we're going to discover the 3 pillars of the mobile center of excellence, hence the MAD title. We're going to talk about microservices, Agile, and then DevOps. First, I'm going to talk about microservice architectures. And why exactly would we consider using mobile microservices to build our center of excellence? Why is this such an important pillar for our organization? Well, the traditional approach, like I said, typically looked at the system of record as the be-all and end-all. And with mobile, we're moving more towards a system of engagement with this interactive device right here in our pocket, with a much richer sensory input than a traditional system like a desktop computer. We're moving away from building monoliths and more towards simple, nimble apps. And traditionally, we would look at these multi-featured systems rather than something highly targeted to need. Now, I'm talking about this in a mobile capacity, but when you think about your service architecture, that's also an important consideration. Not building one huge, big back-end system that does everything, that solves every problem, but instead building many smaller services suited for need. Maybe an orders microservice, maybe a user accounts microservice. We're also moving from long development cycles to much quicker development cycles, which encompass things like continuous integration and continuous deployment. So rather than deploying quarterly, as I said, we would deploy maybe every week, maybe every day, maybe even every code push. If it's made it through the CI/CD pipeline, it's got a green status check, we're good to go. Let's go ahead and deploy it. We're moving from a costly development model to a much more affordable one, where we use the skills at hand to build the microservice that we need, rather than using the one Java developer that we have to build this big monolith. So it's just SOA again, right? Well, not necessarily. So what exactly is microservices if it's not just SOA Mark II? They're small composable services that get plugged together to achieve a broader scope of functionality. They're responsible for small pieces of work rather than doing all of the heavy lifting in one application. And they talk over dumb pipes with smart endpoints. And what do we mean by that? Well, microservices, unlike traditional monoliths, where the path between different components is just within memory in the source code, with microservices, the path between components is HTTP, HTTP2, some sort of message broker. Doesn't matter. That's not the important part. What's important is what gets implemented at the end of each of these endpoints. Hence where we talk about the smart endpoints with these dumb pipes. So we don't really care what the transport mechanism is. They're not monoliths, that's for sure. So when you get to the point where your microservice is doing an awful lot of work, then maybe it's time to start thinking about breaking it out and creating yet another microservice. Because keep in mind, the more the merrier when it comes to microservice architectures. There's fantastic platforms out there for solving the kind of problem of scaling to multiple endpoints and multiple microservices. They're also not a silver bullet. So if you've already got huge problems in building your monolith applications, there's every chance that just moving to microservices isn't going to solve all of your problems. So it's not this one fixed shop for your problems. And it's not just SOA all over again as well, I think. So mobile is quite different as well. We talked about mobile being very fast to deploy, mobile being a little slower to deploy. Now, what do I mean by that? So of course, the demand is there to deploy quickly, but if you think about a traditional web-based architecture where you've built some sort of application that lives in a browser, and your employees interact with this application at their desk, you can deploy an update to that application very, very quickly by simply doing a code push. Maybe it'll take 2 or 3 hours for your WAR file to build and then get deployed onto a server. But eventually, you've got your code out there in the wild, and it's deployed into users' browsers. Now look at a mobile phone device. Look at a device that's maybe connected to a MDM provider in a private app store. Or look at maybe a consumer mobile application living in the public app store. That's a much slower deploy process, and we'll explore this in a moment. You've got much looser coupled API integrations as a result when you're building for the desktop or building for the browser. The API that your web application uses can change a little bit through release cycles without huge consequences. Because the minute you do a deploy of your web application, you can guarantee that the browser, once the cache is wiped and the browser has done a full page refresh, is going to be using the latest spec of the API. If you're deploying mobile applications, there's no guarantee that somebody has actually deployed or updated their mobile phone device and is using the latest API, and your API needs to live for a lot longer as well. You need to think about things like API versioning and also mobile device application versioning. And microservices solves a lot of these problems, allowing you to run multiple services in parallel if you so need. Imagine having to run a version of your monolith in parallel, 3 or 4 different versions, really, really difficult problem to solve. You've also got a much more performant network connection on the desktop, so you can make any size request within reason, and you can make a larger number of requests as well. The size of the payload isn't so big of a concern, but on mobile devices, when your field service workers are out in the field and they're in a tunnel with limited signal, or when they're in the middle of nowhere near a city on an edge network, the network performance itself is much worse as well. And so the amount of data going across the wire is something you really need to think about, which isn't necessarily the case for a desktop application. You can reasonably well assume that your users sitting in front of a desk have proper broadband connection. So some very different considerations for mobile versus desktop. And I think microservices architectures really help to design for these kind of constraints as well. So I talked about the update cycle a moment ago very briefly. And with a web application, you can deploy in a number of hours, depending on how long your deploy takes. For a mobile application, if you're updating using an MDM provider, you've got a pretty good scenario there. You can probably guarantee that within a couple of days, everybody within your enterprise has the latest version of the application. Now, I say days because think of the scenario where the phone hasn't called home, hasn't been online in a while. It's just used in, I don't know, an underground scenario. The application uses offline storage, stores the records, and then eventually gets synced with the backend in a day or two. What if that backend has changed? What if the API that accepts the records that live on the device has changed? So that's a concern for mobile, which never really existed for web-based, browser-based software. So that's the MDM scenario. What about in the public app store? What if you've got to deploy an update to a consumer iOS app with some breaking change to your API? Well, folks, if I open my iOS app store right now, I have 363 pending updates to my mobile applications. I am a really bad developer when it comes to actually updating my apps. So, there's no guarantee that users are going to update the application and get the latest version of your API. And you need to think about things like API deprecation and forcing users to update in the public app store. So there's many different concerns. The performance is very different as well. And I talked earlier about the scenario where users are on an edge network. So what we're doing here is we're comparing 2 different approaches. One using a lot of business logic built on the client side, talking to many different services, not really fit for mobile. Perhaps many different API endpoints in a monolith. That's represented by the blue. And in the red, we have this service built specifically for mobile, what I'm calling a mobile microservice that just deals up a mobile-specific, one cohesive API to mobile without the need to make multiple requests with multiple large payloads. So 2 slightly different approaches. And you'll notice on a 4G network that the difference is almost the same. On 3G, already we're seeing a slowdown with just integrating with some sort of monolith blindly without thinking about mobile. Remember, these are microseconds, so here we're seeing about a 10-second wait versus about a second. When we move to an edge network, we're already up at 30 seconds. Many devices may have timed out, and I can guarantee at least half of your users will have gotten sick of waiting, will have just given up. And when we get to GPRS, we're up to 1.5 minutes, and people aren't going to wait around for 1.5 minutes. So there are some statistics behind this. I didn't just draw a pretty graph, and if you'd like to see the numbers behind it, please feel free to come up to me afterwards. I can point you towards the GitHub repository where the benchmarks were performed. So to summarize, microservices are well suited, very well suited for the development practices of a mobile center of excellency. And if you're not thinking about microservice architecture as an approach to development of your backends within your COE, you may be doing something wrong. You might want to rethink your strategy. They're very well suited to mobile, and they're very, very different from the concerns of delivering for desktop software, and different for developing for a monolith as well. That's microservices. Now to talk about the next pillar of building a mobile center of excellency, I'm going to pass you over to John, who's going to talk a little bit about Agile.
Thanks again. Okay, so going to talk about Agile. Going to start with a couple of home truths about software development. And I'm looking very much at three people in the center of the audience here as I talk about these truths. It is impossible to gather all the requirements up front. I can't do that because I'm being recorded, but back at you, buddy. Whatever requirements you do gather are pretty much guaranteed to change as the project progresses. And there's always going to be more that you want to do than time and money will allow. So very, very uncertain world, limited capacity. So what is Agile and why can Agile potentially help us? So I've highlighted the kind of key terms. Time-boxed, iterative, incremental, uses user stories for continuous delivery in 2-week cycles that we call iterations. So what does all that mean? Agile is a term, it's bandied around an awful lot. People think it's going to be this magic silver bullet and they bring it in expecting 50% productivity increase from developers and it all goes horribly wrong. People have had some terrible experiences with Agile. But when done right, it can be incredibly effective. And it's basically an umbrella term for a lot of different software methodologies. Scrum, XP, Kanban, Scrumban. There's many of them that take the principles of Agile and apply them into a more cohesive framework. So at its simplest, and this seems really basic, but often simple is best. At its heart, how Agile works is you make a list of things. We call this our backlog. You size things up, put estimates on them. Set some priorities, reorder things in the backlog. What do we want to do first? And then you start executing. As you go, you track how you're performing and you update your plan. You don't set up the plan in stone up front and then try and execute against it. The plan is a living, breathing thing that evolves as your project evolves. So how is it different from traditional waterfall software development? One of the main things is that the analysis phase doesn't just happen at the beginning. You're doing all of the activities all of the time in an iterative approach. So every 2 weeks you're doing analysis, design, coding, and testing. Every 2 weeks you're shipping something. As you ship things, as you look at what you just achieved, you learn and you adapt. Within a Scrum or within an Agile team, roles tend to start blurring. You have a group of people dedicated to a common objective with the right skill set to make it happen. You don't delineate between development, QE, and operations. You don't throw things over the wall. You work together as a cohesive team towards a common purpose. You acknowledge that the scope can and will vary. You acknowledge that the requirements can and will change. These are facts of life. Don't fight against them. Embrace them, acknowledge them, and roll with it. And our primary measure of success is not how far along we are on the plan or how far through the tech spec we are. It's how much working software we've actually shipped. Because with this approach, the aim is you're shipping something every 2 weeks. So visually, how Agile is different is you basically take traditional software development and flip it on its side. So rather than doing all your analysis, then your detailed design phase, then your engineering team go dark for 9 months coding, then fire it over the wall to the QE team, you turn that on its side and you do all of them all of the time. You execute through the stack, you review, you refine, and you go again. So if we look at Agile and Waterfall in terms of 4 characteristics: quality, visibility, risk, and change. With Waterfall, you tend to have quite poor quality because all the testing is left till the end. Typically, development overruns. The release date can't move, so testing gets squeezed. Whereas with Agile, you're building testing into everything you do. Within every 2-week iteration, a portion of that time is testing. So you're getting testing right from the start. In terms of visibility, with waterfall, because of the waterfall-esque style of it, you have to really wait until the end to see whether you've been successful. By the time you reach the end of the design phase, you might be a third of the way through your project, you haven't written a line of code, and you really don't know whether all of that planning and all of that design is going to be effective and is going to be accurate. In fact, you're pretty sure it's not. Whereas with Agile, your visibility is really good because you're reviewing the plan, you're reviewing the priorities, and you're incrementing and iterating every 2 weeks. In terms of risk, there's quite a high risk of failure with Agile. There's a risk to your schedule, there's a risk to your technical delivery, there's a risk to your product feature set. Whereas with Agile, you have very low risk. You get to set priorities up front, and you get to iterate frequently and ship frequently, giving you early feedback. With regard to ability to adapt to change, waterfall is very, very poor. So much time has been put in up front in the planning and design phase that people really don't want to change the plan. There's been so much effort put in, it's going to be so much effort to review it and get it approved again, people don't want to change it. Whereas with Agile, change is welcome. It comes, we deal with it, it comes onto the backlog, it's estimated, it's prioritized, it's executed on. So back to visual again, in terms of the frequent releases. On the left-hand side, yes, it is on your left-hand side, we have green, we have Agile. We're doing very frequent releases, the risk is very low. We're doing it very often, we're becoming very proficient at it, and we're releasing smaller increments of software into our production systems. Whereas with the waterfall methodology, you're typically looking at 3, 6, 9-month development cycles, very, very large drops of software, incredibly risky because of the amount of things you're changing in one go. Okay, so I spoke a little bit about a backlog. That's all of the work we want to do. And backlog prioritization is one of the most important things that you do in Agile. You're constantly looking at what's in the backlog, what's coming up next, what's coming up in the iteration after that, even the one after that, and you're planning typically 6 to 10 weeks out. That is what you should be doing. You have your backlog stocked with the work you know you want to do over the next 3 iterations, and you're doing your planning, you're in Agile long-range planning, on 6 to 10 weeks out. So you're doing very, very frequent and small reviews, moving along with the project as it moves. Prioritization on the backlog needs to be managed by one person who represents the stakeholders, and that one person should be your product owner. The product owner should be the one with feedback from everyone else to make the decision on order of product priorities. As you're looking 3 to 5 sprints out, you'll find pieces of work that have large estimates on them. There's not enough known about them. So you're looking to start breaking down those work, pulling in some investigative tasks in to the next sprint so that you can better estimate on that work that's 3 to 4 to 5 sprints or iterations out. User stories are a way of describing what you want the system to do. Basically, a fairly short, high-level statement of a desire or a request for a piece of functionality in the system. Typically just enough to start a conversation. They're very often written as a person, I want something so that I can achieve something. So as a developer, I want coffee so that I can stay awake and program, would be an example of a user story. And then you take them and you start asking questions about them, teasing them out, breaking them down into smaller stories and smaller stories until we have them at a level where they can typically be worked on within 3 to 5 days by a single engineer. That's about the size of stories we want. So we have very good visibility and very good feedback, even within the 2-week period, as to how we're progressing. When it comes to estimation, it's a very tricky thing to get right. For a long time, people tried to estimate in days, but there's a terrible bias in terms of estimating in days. What is a day? How long is a day? Is it a junior developer's day or a senior principal engineer's day? How many meetings does someone have? It's very, very difficult to get accurate estimates with days. So instead, what Agile recommends is an approach called story pointing, which is you give your stories a relative size based on complexity. So you decide what a really, really simple story is, and you say that's 1 point. You find one that's a little bit more complex and you say that's 2. Then you pick one a little bit more complex and you say that's 5. And once you've agreed on 1, 2, and 5, you then start estimating your other stories relative to them. And within an Agile team, typically the way you do that is you use a technique called planning poker. It can be done physically in a room with a team or online with a distributed team. And that's where everyone has a set of cards, either physical or virtual, with these numbers on them. And when a story is being discussed, each team plays a card, then they're all revealed, and there's a discussion within the team on the various pointing that people have provided, and based on that discussion, consensus is reached. So there's no one person leading the estimation, setting biases. Everyone gets to put a vote in, and then a discussion happens. And it's been proven to be a very, very effective way of estimating work. Okay, so then in terms of planning, we do always want to have a plan. We want to know when we're going to ship. We do have to answer these questions. So to help us with planning, we have a couple of tricks that we can use within Agile. So the first is the term velocity. And what velocity is measuring the speed from story to product. So from the time you get a story in to the time it's shipped as a product. And you measure that using these story points that we saw in the previous slide. So within a 2-week iteration, my team of 8 developers can do 130 story points. I have this much of a backlog. It has 1,700 story points on it. We're looking at about 12 more iterations. We have to ship an 8, which means about 1/3 of the work on the backlog is not going to get done if we want to meet the delivery date. And we get that information very, very early. Typically after about 3 sprints, you have enough information from velocity to be able to start doing projections on estimated delivery date. One of the tools we use quite a lot for this is called burn-down charts. And there's 2 different types of burn-down charts. So the one at the top right is a burn-down chart within a 2-week period. So if we look very closely, we can see that at the start of that iteration, there was almost 100 story points. The gray line represents the ideal burn down throughout the sprint. The red, more steps of a stairs line represents the actual burn down. So we can see in this sprint, the team did successfully achieve about 100 story points. And how did they know they could do that? Based on the information from the velocity of the previous sprints. The chart on the bottom left then is one that shows us at the iteration or sprint level. So we can see in this case, we've had 5 sprints completed, and based on the work that was done in those 5 sprints, our software can tell us we have 7 sprints remaining. We know how long a sprint is, we know when we should be able to deliver. So very transparent, very visible, adaptive planning for free from your software tool, basically. So I've talked a good bit about iterations already, but just to circle back on them. So they're a time box period of time, typically 2 weeks, but it can be anything from 1 week to 4 weeks. To start an iteration, you take the highest priority stories from the backlog that have already been ranked by the product manager in consultation with the rest of the team, and you bring them into your sprint, and then your team starts taking stories and working on them. By the end of the sprint, your aim is to have produced a shippable increment. So you should be theming the work you bring in. So you're bringing in a set of features for 2 new screens. By the end of the sprint, they may not be fully functional, but they could certainly be shown to a customer as in, this is what we are in the process of developing, and get early customer feedback. Shippable increment doesn't necessarily mean fully working production grade software. It means something that moves us forward, that can help us progress a discussion, help us progress a sale, or ship updated software. And as I said, with iterations and velocity, past performance actually is a guide to future performance. So assuming your team structure and team members stay the same, then the velocity from previous sprints is a very good guide of the velocity the team will achieve on an ongoing basis. So back to picture mode. This is what an iteration looks like. On the left-hand side, you have your backlog of items ranked in priority. Within the iteration, you bring in a bunch of work. The team collaborates. They have daily reviews to track their progress using that burn-down chart we saw from within the iteration. And at the end of the iteration, they deliver some shippable increment. They do a retrospective and review on the work they've just achieved under processes and procedures, and look at how they can adapt and improve for the next 2-week period, and then do it all over again. So all of this is really summed up in what's called the Agile Manifesto. And the Agile Manifesto says, in the 4 bullet points, we do value the items on the right-hand side, but we value the items in bold on the left-hand side more. So we value individuals and interactions. We value people talking to each other over processes and tools that may get in the way. We value working software over comprehensive documentation. That's not to say that you cannot do documentation. Documentation is essential. But comprehensive documentation doesn't necessarily mean product documentation. It also means not having big, heavy plans and technical specifications, having adaptive, smaller documentation. We value customer collaboration, working with the customer to understand what they want and need and delivering it to them over officious contract negotiations and talks of change and scope. And we value much more responding to change over following a plan that has been laid out perhaps months ago. So that's it for me for Agile. I'm going to hand you over to Philip now, who will talk about DevOps.
Thanks very much. So as John said, I'm going to take you through DevOps and how that relates to a mobile center of excellence. So John has talked about Agile. So when we talk about Agile, are we talking about Agile within a development environment or Agile within an enterprise? So if you look at how Agile can help throughout an entire organization, the idea is to get to full DevOps through the integration of all the various different departments within the organization in order to build and deploy and monitor the software. So Agile relationship between the development and IT operations shows here where the build cycle is a continuous cycle between building and releasing and operating and monitoring that software. So it's essential really that all parts of the organization are integrated and fully built into this cycle. So we're going to look at some example tools now which we would tend to use when we talk to our customers about how they would implement their mobile center of excellence. There's a number of tools that we refer to. I suppose starting off with a continuous integration server, we tend to do a lot of work with Jenkins and things like Circle CI and so on. But effectively, these will look after doing the building and running the tests and so on, and then performing various actions then depending on the outcome of that. Git source code management is central to pretty much everything that we do within the mobile platform, and it's central to the DevOps cycle as well. I've recently been doing a lot of work with Ansible in conjunction with the Red Hat mobile application platform. I'm going to talk about how we use that in order to automate the creation of projects, so that we can automate the creation of the pipelines and so on at the Jenkins level as well. So clearly the Red Hat mobile application platform is central to this from our perspective as well. So it provides a lot of the tools that are required in order to complete the development life cycle, to do things like create builds of application binaries and to deploy cloud code, those types of things. There are a number of build tools which we would also use as well, such as Grunt and Maven and so on, depending on the technology. We also use a number of different testing frameworks as well. Testing is integral to DevOps. So from a developer's point of view, I certainly like to write my tests as I'm writing my code, and I can be sure that I'm not implementing any breaking changes as I develop new functionality. I can see that all of my tests and so on are passing. There's a number of command line tools that we would also use as well through this process that will perform a number of different functions, like interacting with the mobile application platform or interacting with OpenShift, for example. A range of different external services. So we may integrate with Slack, so you could have a notification that a particular build is completed to tell you, to ask you whether or not you want to promote that out to a test environment. That can all be done with things like Slack. Monitoring is central as well. So we also always recommend incorporating very, very good health monitoring functionality on the cloud side of applications and integrating that then with monitoring tools as well. And there are a number of NPM modules that we would tend to recommend, and our customers would incorporate those as standard when they are creating new applications. So I'm going to talk about that kind of flow now with a typical sort of integration life cycle. So if we look through that, hopefully the writing is clear for everyone to see. But it starts off with the developers. So the developers, you know, they complete their story. They push that up to Git. Once all their tests and so on have passed locally, that then gets pushed up to the source code repository. The integration server then will tend to pull those source code repositories and pull down then the latest version of code. At which point then a pipeline is then triggered then, which will go through a number of different tests then based on the configuration by the team. So for example, it may need to run the unit tests and the acceptance tests and so on. And once they pass then, it could then push that code up then to RHMap, which would then cause the platform then to build a binary or to deploy that then to a test or a production environment, for example. When we come to look at what we can do with the Jenkins environment, there can be a range of different things happening there as well, such as running Android emulators, for example, to run native tests or to run Selenium, to run sort of client-side tests on things like hybrid applications. But it's all that sort of configuration that we like to then look at automating through process automation. So it's not enough really to have DevOps once you've created your project. So, you know, we're not recommending going through a manual process of creating a project and then, you know, creating the users who should be, you know, allowed to work on that project, assign them to the various different permissions within the Red Hat mobile application platform, or, you know, then going into Jenkins and creating a job and defining the pipeline and getting all those sort of things in place. So when we talk about a mobile center of excellence, we talk about building these tools so that they can be run automatically. So, for example, we've recently been working with clients to automate this entire process using things like Ansible. So an example there would be, rather than, as I said, creating a project manually, a script would be run which would using the command line tools, create a project in the platform, create the users, create the teams, and assign the users to the project and so on to the right teams and the right users. But then create the applications then within the project. So if it's a native client application, to create that, to create the cloud applications, and do all that from a script. And then create those pipelines then within Jenkins as well. So everything is done then from start to finish, and everything is standard within the organization. And that would include things like standard modules. So the organization may always require standard logging modules to be present in their cloud applications, or standard health check modules. So all of these will always be there and standardized, and the project is created automatically, and then it's just down to the developers then to use the pipelines and so on that have been created within Jenkins for them. So that's what we try and get to, as I say, to take the manual steps out of this whole process. So if we look at it, this is a typical pipeline that we may develop. This is an example from Jenkins. I don't know if anyone can see there, but you can see the various different steps here. So once the code is pushed up to the Git repository, once all the local tests have been passed, Jenkins will then go and check out the code. It'll install any dependencies that are needed for that code. So if it's cloud code, it will do an npm install any updates to the node modules. It'll then run the tests then that are configured to run. It'll then configure then the FHC, because generally we need to make sure that we're logging into the feed Henry command line tools with the right permissions and so on. It'll then trigger a cloud Git pull, so tell the platform to pull down this code from the Git repo, and then deploy that then to the development environment. And typically that'll all be done without any user intervention. So simply the developer pushing up to the Git repository will trigger this pipeline. So without any intervention, it'll then be deployed to the development environment once this pipeline has progressed, and they can then test that then in that development environment. To move on to the next stages then, so for example, to deploy to the UAT environment, UAT environment, there's generally a manual question then that needs to be answered at that point. So to proceed to that next step, and similarly then to the production environment as well. So, and again, that could be done through Slack or some sort of integration that way. But again, at that point, then there are generally manual interventions at that point. So where does the Red Hat mobile application platform fit into DevOps? It provides a number of different ways of creating projects and creating apps within those projects. So again, to do that, without simply going into the platform and creating them, you can build these into scripts to create those for you. So they're all done in a standardized manner. There are a number of different unit and acceptance tests that get created automatically when you create applications within the platform. And these are very good starting points for you then to be able to build on those and as developers as a good foundation then to work from. There's a number of different ways to deploy the updates within the platform. So again, that can be integrated with continuous integration tools. There are very strong lifecycle management tools within the platform to ensure that exactly the same Git commit is deployed throughout all the different environments within the organization. So you can be absolutely sure you've got the same code base through development, through to UAT, through to production. And that can be all managed through lifecycle management. And the same for client app development as well, to ensure that exactly the same code base that has been tested all along gets deployed out. Health endpoints is something that's central to again, it's part of our recommendations for Center of Excellence. So that there's a widely used health module that we recommend, which will expose a very, very simple JSON object, which will tell the operations team whether or not there are any issues with the cloud code or the services. Generally, deployment to UAT in production tends to be more controlled, so we can lock that down to various different users being able to do that. So for example, a developer might not have the ability to actually log into the platform and perform a UAT or a production deployment. That could be done by a member of the operations team. But then binary creation as well is also critical. One of the things that we like to talk about is taking the skill or the tools for binary creation away from the developers and moving those to a build manager within an organization or part of the operations team. And again, that can be all triggered and done as part of a pipeline automatically. So through a continuous integration platform, a development binary could be built and made available to the development team to test. And once that's passed, then a UAT or a test build could be built, and similarly for a production one. And also then we can integrate them with MDM then to deploy those binaries then once they're done. So there are a number of different things which are kind of critical to a full DevOps pipeline for mobile that are provided by the platform at that level. Okay, so I think that's the end of the DevOps section. So I'll leave it back to you, Keane.
Philip, thanks, John. So we've seen the mobile COE. We've seen it brings new release cycles to an organization. We've seen it brings this whole new pace of business as well. And so it allows us to deliver software differently. And hopefully through these three different pillars that we saw today, with microservices allowing us to develop services for our mobile apps to talk to at a much quicker pace, with Agile allowing us to look back at the work that we've done and do retrospectives, improve, and allows us to deliver much quickly as well with things like time-boxed sprints, story points, and proper planning and estimation. And also with DevOps, the pipeline that allows us to develop and push code, continuously integrate, continuously deploy, get stuff into production much quicker, and allow us to move at the pace that the mobile center of excellency, driven by the desires of various business units in an organization, demand. We also see this greater return on investment on the dollar IT spend that we see in an organization. And so really, hopefully today, the key take-home is that the mobile center of excellence is probably the most important strategy to think about when developing a mobile strategy for a business, and it is probably the best way to go about achieving mobility success, mobility zen. So that's been our presentation. Thank you everybody so much for staying until the graveyard shift, which I believe is the last summit presentation of the day. Hopefully everybody's enjoyed it. And if you have any questions, please feel free to ask either now or indeed come up to us at the end of the event. Any questions? Going, and gone. You are free to go.
I have a question.
John has a question.
Can we go to the pub now?
Can we go to the pub now? Yes, John, we may go to the pub now. Thanks, folks.